In the electrolysis topic, you'll be expected to predict the products of electrolysis and also explain and evaluate various different processes that are specific examples of electrolysis. When an ionic substance is melted or dissolved in water, then the ions are free to move about. This means that they can now conduct electricity. The positive ions will move to the negative terminal, the negative ions will move to the positive terminal. Breaking down a substance like this is called electrolysis, and the substance you are breaking down is known as the electrolyte. In electrolysis, the positively charged ions, which are known as cations, will move to the negative electrode, which is known as the cathode, and the negatively charged ions, known as anions, will move to the positive electrode, which is known as the anode. So your anions move to your anode, your cations move to your cathode. If you're struggling to remember which is which, use the mnemonic. The positive is the anode, the negative is the cathode. Don't panic. Remember as well that your cation with a T, like a positive, is your positive ion, and your anion with an extra N is the negative ion. At the negative electrode, the cathode, the positively charged cations will gain electrons. So your positive cation will gain electrons from the negative part of the electrode. The positive electrode, the anode, your negatively charged anions will lose electrons. So they are currently negative and they will lose their electrons to the positive anode. The negative electrons will be attracted to the positive anode. These processes are known as reduction and oxidation. Again, if you're struggling to remember, use another mnemonic. So oil rig, oxidation is loss of electrons from the anion to the anode. Reduction is gain of electrons, where the electrons move from the negative cathode to the positive cation. These changes can be represented by something called half equations. So these are just showing what's happening to the ions and electrons at the electrodes. One example is 2-chlorine minus turning into Cl2 and 2 negative electrons. This is something that would happen at the anode, where the negative chlorine anions will give away their electrons, so they will lose electrons in oxidation. At the cathode, positive ions, things like H+, for example, would gain electrons. They would be reduced. And in the example of 2 H pluses reacting with 2 electrons, we would form H2 at the cathode. Specification point D starts to mention some of the specific processes you need to know that are examples of electrolysis. Here it mentions electroplating objects, things like copper plating and silver plating. A lot of items used in interior decorating are now copper plated. In copper electroplating, you take the metal that you're wanting to plate or coat in copper and use that as your cathode. The copper itself, the pure metal, is used as the anode. And you also have a solution of copper sulfate, so a solution made up of copper 2+ ions and sulfate SO4 2- ions. In this solution, the copper 2+ ions will move to the negative cathode, where they will gain electrons. They will be reduced into the copper metal, which will coat the metal that you are wanting to copper plate, that you are wanting to electroplate. Silver plating is often used in making cheaper versions of jewellery, where a cheaper metal is just coated with a thin layer of silver rather than the jewellery being silver all the way through. This works in a similar way to the copper plating, but instead of a copper sulfate solution we use a silver nitrate solution, and the silver ions are attracted to the object being plated, being covered in silver, and they are attracted to the negative cathode, where they will gain electrons, where they will be reduced to form a layer of silver over the object you want to silver plate. Both of these processes with copper and silver are known as electroplating. Two more examples of how electrolysis is used is the electrolysis of aluminium oxide and cryolite to make aluminium, and the electrolysis of sodium chloride solution, or salt solution, or brine solution as it is sometimes called, to produce hydrogen and chlorine and sodium hydroxide. With the electrolysis of aluminium oxide, cryolite is used to lower the melting temperature of your aluminium oxide, so less energy is required. That aluminium oxide needs to be molten in order for the ions to move to be separated. The diagram for this looks a little different to the ones we've seen before, but there are still the cathode parts, the negative electrodes, and the anode parts, the positive electrodes. Your aluminium metal will form at the negative electrode because aluminium is a positive ion, a cation that will move towards the negative electrode and will gain electrons and is reduced. At the positive anode, oxygen is formed. But here, the thing to remember is that your positive electrode, your anode, is made of carbon, and so the carbon reacts with the oxygen and you actually get carbon dioxide made. So your two products are the aluminium formed at the negative electrode and the carbon dioxide being produced at the positive electrode. The carbon electrode gets used up, so it has to be replaced. Because the carbon is reacting with the oxygen, it is being used up in that reaction, and therefore the electrode will eventually run out. The electrolysis of sodium chloride, or salt solution, or brine solution looks a little more familiar. You have the sodium chloride solution that has sodium ions, Na+, and chlorine ions, Cl-, and those ions are dissolved in water, which is H2O. We can consider this to be H+ and OH-. That means that you would expect your Na+ to be attracted to your negative cathode and for sodium metal to be formed. However, you must remember that looking at the reactivity series, any metal that is higher than hydrogen in the reactivity series will actually result in hydrogen gas being formed at the electrode instead of that metal. You do get given a copy of the reactivity series in the exam, so make sure you check for the metal that you are thinking might be produced, whether it is more reactive than hydrogen and therefore hydrogen will be produced, or whether it is less reactive than hydrogen, in which case the metal itself will be produced instead. As we said here, your sodium is more reactive than hydrogen, it's higher than hydrogen in the reactivity series, so here we won't get any sodium metal formed, we will get the hydrogen gas formed instead. The Cl- ions, the chloride ions, will be attracted to the positive anode, and here they will lose electrons, they'll be oxidized, and they will form chlorine gas, which is Cl2. That means we still have our Na+ and our OH- ions left, and that's how we form sodium hydroxide. Na+ and OH- makes NaOH, sodium hydroxide. You need to know the uses of these products, so things like sodium hydroxide can be used for the production of soap, and chlorine can be used for the production of bleach and plastics. Hydrogen is being considered as a fuel source. You will need to know all of the half equations for all of the examples, the electroplating using both silver and copper, and the extraction of aluminium from aluminium oxide, and the production of sodium hydroxide, hydrogen and chlorine from sodium chloride solution. If you're not certain what these half equations are, try checking in your revision guide or asking your teacher.